Hello everyone, welcome back to another tutorial. In today's video, we want to continue our series where we look at how to work with Codesys Control for Raspberry Pi. And in the previous video so far, we have looked at how to install and configure the Codesys Control runtime for Raspberry Pi on a Raspberry Pi. And we've also looked at a few examples, creating programs for the Codesys Control runtime for Raspberry Pi. And so we are going to continue in that direction. Basically, what we've done so far is we've looked at an example working with the I2C interface. And today's video, we want to look at how to work with Modbus RTU. So a little bit of the setup that I have here. I have my Raspberry Pi here, as you can see on top here. And it's a 3B. And on the bottom here, I have ABB AC500 V3 controller here. In this setup, what we want to do is we want our Raspberry Pi to be the Modbus RTU Master, and it will be reading data from the slave or server, which is this controller here. So the controller here, the ABB controller, is the Modbus RTU Server, and our Raspberry Pi will be the Modbus RTU Master, this setup here. Now, to work with RTU with the Raspberry Pi using the Codesys Control runtime, you basically have two options on how you can make your connection communicate with the server there, read and write data. One of the options is to connect via the USB interface, and the other option is to connect via the serial GPIO serial interface. Now, if you remember correctly, I'll minimize this a little bit to show you what I'm talking about here. So if you remember correctly, if you look at the pinout table here for the Raspberry Pi, you have these GPIO 14 and 15, and these are designated as UART0 and UART0 TX and UART0 RX. So this is the serial. These are the serial pins on the GPIO interface there. So you can either connect via these pins here, or you can use the USB interface. We're going to see both approaches, but for this video today, we're going to look at the USB option first, and then later in a separate video, we shall look at how to use the serial pins on the GPIO interface here. Okay, so this is the example that we looked at last time. We saw an example on how to work with the I2C interface, and we are going to basically continue in this and build on that, and then see how we can set up and configure a Modbus RTU Master to read data from the slave. So before we start in the Codesys environment here, there are a few things we have to configure on the Raspberry Pi on the Linux side of the Raspberry Pi. And that's what we're going to do first, and then I'm going to take you through step by step on what you need to do and things of the kind. So let's start with that. So open up my PowerShell here. I want to log into the Raspberry Pi over SSH, and I'll do that. So I'll type here SSH. SSH username is Pi, and then the IP address is 192.168.1.37. And then it asks for my password, and then I'll enter the password as well. Oh, did I miss that? Okay, I'll try again. Okay, now I'm logged in here. So to use the USB approach, you need some extra hardware to make this work. So for example, here, as you can see, I'll show you here on my setup here. The controller here has an onboard serial interface where I can connect and then establish Modbus communication over that interface. So this interface supports both RS-232 and RS-485. So if I want to establish Modbus RTU connection to this controller over USB, so that means that it will be USB on my Raspberry Pi side, and basically it's just two wires here. For example, this configuration right here is RS-485. So two wires for RS-485 here, and then USB on the Raspberry Pi side. That means I need something like this. So this is an RS-485 to USB converter. So it converts the communication coming in here over RS-485, and then it converts it to USB here. So you would need something like this. If you're using RS-232 on this interface, again, you would need another converter which could convert for you RS-232 to USB. So that is all you need. You need the master, which is the Raspberry Pi there. You need the server, which is the controller here, and then you need to convert that to communication. So from RS-485, the way I have it here right now, to USB, and I'm using this RS-485 to USB converter here. So that way I can establish Modbus communication, read and write data like that. So what we want to do first is we want to make sure that our Raspberry Pi can detect this converter on the USB interface. So what we do, I'm gonna connect this to one of the ports here. Okay. Now on this side I have USB, and then it converts to RS-485, and then the RS-485 goes to the controller here. Now if I go back to the Raspberry Pi here, I need to make sure that this device is detected on the USB interface. So what I'll do ls/dev, and you should see something like TTY SCM. Okay. So you should see something like TTY SCM 0 or TTY USB 0, something like that. But so you can see that the device there is detected as a TTY SCM 0. It's detected on this interface here. So this is the device file representing our converter here. So we can access our converter via this device file there, as you can see. So it's TTY SCM 0. Some converters appear as TTY USB 0. So it depends, but you want to see this. So after knowing which device file you can access your converter from, then we go to the next step. The next step is we have to edit the Codesys Control user config file. So basically, we are mapping ports to specific devices, as you'll see. So I can do for you a cut here. So we are the Codesys Control user config file is stored in etc under Codesys Control, and then it's under Codesys Control underscore user. So Codesys Control, sorry, underscore user dot config. And this is the file we need to edit. So you can see that under syscoms here, this is where we are supposed to do the mapping for our ports. So we map a port number to a specific device. So for example, here, this USB RS-485 to USB converter will be mapped to a specific port so that we can access it in the Codesys environment or in the Codesys world. So that's what we're going to do. So I'll come back here and say, now I want to edit this. So I'll say sudo nano, and then, sorry, sudo nano, and then the Codesys control user config file. Now I need to go down, like we said, under syscom here. And all we want to do is to do the mapping. So the mapping works like this. So we say Linux, okay. Linux dot device file dot one equals. So our device file was slash dev slash tty scm0, like that. So we are mapping that device that is detected on the device file tty scm0 to port 1. So the 1 here represents the port number. So that means in the Linux, in the Codesys world, if you want to access the device, then we just have to specify that it's running on port 1. If you want it to be on port 2, then you just put the 2 instead of 1. But we want to put it on 1. So that's how you map your devices to specific ports. If you had multiple devices, still you can map them on a new line, then you add another Linux.device file. Now .2, for example, and then you map another device there. But since we have only one now, we shall leave it at that. basically that's what you need to do. Then you can save the file, and then we need to reboot the Raspberry Pi. Okay, so we are done with that configuration. Now we can come back here in our Codesys environment. And the first thing we want to do now is we want to add a communication port. So I come here to device, I right click, and then I go to add device. And then you can see that I can browse under Modbus, then under Modbus serial port, and then I select this Modbus COM. So we add a COM port there on our device tree, and I can close this. And then, so you can see now we have a COM port device added on our device tree here. The next thing we need to do is to right click again, and then we attach a Modbus client on this COM port. So you can see we have under field buses, under Modbus, and then under Modbus. Since this is a master, so we add a Modbus master, call it a client device on that port there. I'll go ahead and add that. And now on this master device here, or client, now you can add different Modbus server devices that you want to communicate with. So if we had, for example, I don't know, 3, 4, how many servers we want to communicate with, we have to add a separate device for each server that we want to communicate with. So since we have only one server here, so I'll go right click, add device, and then I'll add a Modbus server there. And that's that. So we have a COM port, then on the COM port we add a Modbus client or master device, and then on the master device we add a Modbus server for each server we want to communicate with. Okay, now we've added everything we need. Now we just go into the configuration. So first, for the Modbus COM port, you need to set these communication parameters. So this should match the server you want to communicate with. So for example, so see here, the first thing you want to configure is the COM port. Remember we configured our device there to be, it's running on COM port 1. So we select 1 here. The bound rate, this should match the server bound rate. So I know that my controller has been configured with this 19,200 bound rate. The parity is none. Data bits is 8 and stop bits is 1. And basically that's it for this. There is nothing more. It's just a port. It should match what you've configured on the Linux side. And then this should match the server properties as well. And then on the master here or client, now you select which Modbus you want to use. You can select either RTU or ASCII. We're using RTU. You can set this response time to what you want and time between frames as well. I'm not going to change those. I'm going to leave them as they are by default, and that's it. And now the remaining part is basically to read data from the server. So on the Modbus server here, you want to set the server address. So assuming you have multiple servers on the same line, so you have to select which server you want to communicate with. So here my server is on address 1, and then response time I'll leave it to 1000 milliseconds or 1 second. And now I have to write the logic to read data from the server. So here also there are 2 approaches. We've seen some of the approaches before. So you can either use Modbus channels, or you can use function blocks. So function blocks are more flexible. You write them in any language you want, and then you can change parameters during runtime. So you can either use a function block. There is a library dedicated for configuring this communication. But if you're really in a hurry, you can use channels also come in handy. So we're going to use channels in this tutorial. So under Modbus server, I come under server Modbus server channel here. Then I want to add a channel. So each channel basically performs one function. It either reads or writes data, depending on what you want to do. So add a channel here, call it channel 0, and then you define the action you want to do here, or the function you want to perform. So I want to read holding registers, and then you set here the trigger method. Is it cyclic? Is it a rising edge or something like that? Cyclic means it runs continuously depending on a set period or cycle time that you want. So I want this one to run cyclically, and then I want to run the cycle time to be 100 milliseconds. So to run every 100 milliseconds and to be reading data. Then here you set where you want to read from and how many sets of data you want to read. So I want to read from register 0 because I know that is where the data that I want to read is mapped on the server side. So register 0, and then I'm gonna read just one register. And basically that's it. I've configured my channel. This channel reads from the holding registers, and it's reading register index 0, and it's only reading one data set. And that's it basically. And I click OK. Now, when you're working with channels, if you want to use this data, of course, you want to use the data in the application, then you have to map a variable to the registers you're reading from. So for example, when I come down here and Modbus generic serial server IO mapping, you can see that I can map a variable to this register that I'm reading from here. So I'm reading one register, like we said, so I can map a variable here so that I can use the data in the application. So what I'll do, I'll come in the application here, then I'll create a new variable here. I'll call it MB data, for example, is of type word. And then I can map this variable on that register in the channel there, and then I can use the data in my application here. So I'll go back here under Modbus IO mapping, and then I can map that variable that I just created here. So it's MB data there, mapped, and it's done. And now, basically, that's it. I think there isn't anything more here. And we should be basically good to go. Okay, so simple recap: add a comport to the device tree, add a Modbus client device on the comport, add a server you want to communicate with, and then add a channel or channels to perform different functions, and then map variables to the registers you're reading from the server. And I think we are good to go. Okay, so first thing, I want to make sure my runtime is running already. So I'll bring up this deploy tool, username, password, and then I'll try to connect to it. Okay, now I'm connected to the Raspberry Pi. I need to go under operation here, and then you can see that both the Codesys Edge Gateway and then the Codesys Control both are running. So everything looks good. Okay, so I'll close everything here. And now I can scan my network, find my Raspberry Pi there. And then I want to upload this program on the Raspberry Pi. Yes. Okay, program is uploading now. All right, program has uploaded, and then I just put this to run. And then you can see basically on the device tree, the COM port, the COM device is running, is green. So that's a good sign. The Modbus device is also green. That's a good sign. And then the Modbus server is green also. That's a good sign. So we should be now getting data. So you can see right away here that we're getting some data. And then we can go ahead, for example, and visualize what this data is. I know that the data that is coming in here is an output of a sine generator. So this data is basically a sine wave. So what we can do, we can go in our visualization here. We want to add, for example, a trace graph here. On this trace graph, so we can configure this. Come here, I'll say add a variable to this trace graph, and then I'll browse for the variable. Okay, I think before we add a trace, we add the variable to the trace graph there. We need to convert it because this is a word. So that means we need the negative values because this is a sine wave. We need the real negative values. So we need to convert it from 1 to int to get that exact negative value for the amplitude when the amplitude is negative. So I'll add another variable here. I call it idata, and then it's of type int. Then I'll come here, idata will be equal to, so I'll convert this from word to int. Then I'll convert, basically it's this one that I'm converting from word to int, and then I should get the real value, because you know how negative values are represented in as words. So we want to get the real, the exact value by converting it to the integer there. Then when I come back here, I just again go back, pull this up here, add variable. Then I'll browse some. I want to add this iData, and then these look okay to me. Click OK there, and then I can go to advanced task. And use the main task. Then I want to go to advanced here. I think I should put this to around 10 milliseconds. And the display all looks good. Okay, then I can upload this back to the Raspberry Pi, and then we see what we get. I'll upload the program again. Okay, program is uploaded. I'll put it to run here. Then we should start seeing the data. So you can see, so the amplitude is 500. So it ranges from minus 500 to 500, and then you can see that it's a sine wave as expected. So that's the data we're reading from the server there. So I think that's it for this demonstration. And next time we shall look at how we can use the serial interface on the GPIO interface there. But okay, that is it for this tutorial. Thank you and have a nice day.